Okay. So, good afternoon, everybody. Hope you are having a good day. Good afternoon, KARHALE sir. How are you?
Yeah, fine, fine. Good afternoon to all and you also.
Okay, good afternoon, sir. So today we are fortunate enough to have with us Shankar KARHALE sir. Sir is presently working as a corporate environment and sustainability head at the corporate head office of Aarti Industries, Vadodara. Sir had studied BE in chemical engineering and masters in ecology and environment. Sir has also done post-diploma in industrial environment technology and management and diploma in industrial safety. Sir is a Government of India certified energy auditor, ISO 14001-2015 lead auditor, and responsible care lead auditor. With over 30 years of experience in chemical industries, CETPs, and common TSDF sites facilities covering safety, health, environment, sustainability, and manufacturing, Sir is supporting 16 manufacturing units and four greenfield projects. We welcome you, sir, as a distinguished speaker for today's session. Over to you, sir.
Yeah, thank you, Dr. Hiral, for introduction. And I will present my PPT. This is visible PPT.
Yes, sir, it is visible.
Okay. So this is an interaction section, or how miss all people will interact.
So, you will be giving the session for 1 hour and 20 minutes. And after
Okay.
that, we shall be having 10 to 15 minutes interaction.
Okay. No issue. So today we'll see the 1 hour on the outcome of environmental management system audit, because any environmental management systems in chemical industry is environmental management auditing, monitoring, and environmental management system performance is a very very important particular to manage that show. So I will take up with some pesticide sector, particularly in chemical industry, because pesticide sector is a very important sector in chemical industry due to the toxicity and all these things. So I will go through particular pesticide sectors. You'll get ideas about all sectors also if you have completed this exercise. So pesticide, if you see, the India is the fourth largest producer of agrochemical after USA and Japan and China. Consumption of pesticide in India is a 600 gram per hectare. Consumption of pesticide developed countries is a 3000 gram per hectares. So few acts also applicable in India, like Insecticide Act 1968, Insecticide Rule in 1971. I have given here link also. So if you go through the that CIB board, Central Insecticide Board website, you'll get all information also. So sector agriculture, the sector manufacturing, all control pest, weed, rodents, etc. Public health, this utilize this product for control malaria, dengue, fever, cholera. Other than agriculture and public health, control of vegetation in the forest and the factory site, domestic, household, and garden spray, control the animal and birds. Personal for application of clothing and the skin care also. So material building, incorporation of the paints, glues, plastic, insecticide, herbicide, fungicide, and others. So if you see, the pesticide sector has covered almost all areas, and we are utilizing that also. So pesticide manufacturing, chemical reaction involved, like other sectors involved, like alkylation, bromination, chlorination, acetylation, condensation, crystallization, all chemical reaction, like as chemical industry like pharma, dyes, all industry have chemical reaction. Here also pesticide sector also chemical reaction. Here also batch and continuous mode operation, semi-continuous also distillation, extraction, crystallization, filtration, evaporation, all unit operations utilized in pesticide sector also like pharma and other chemical industries. Reaction also A plus B is equal to C plus D, sometimes D plus E and equal to A. Reaction 2. If I see the reaction 1 is a normal reaction like other sectors have. Only reaction 2 is a slightly toxic reactions here in pesticide sector. So all chemical utilization in pharma, dyes and other sector, rubber, all these things here also utilize. Only last reaction have some toxicity. So you have to take care of the last stage of reactions. Otherwise normal reactions. So here F is a pesticide and other is the raw materials and intermediates up to E. My voice is clear, na? Anyone?
Yes, sir.
Yes,
It
yes,
is clear
yes,
and
sir,
audible.
clear.
Okay, okay, yeah. So types of pesticides and utilization is a very, very important because you should differentiate. Otherwise, there may be hazard also if you are not properly distinguish the what is the use and how to utilize this pesticide is a very, very important because right now if you see the pesticides coming in food and vegetables, that is only one reason utilization of the pesticide is not properly, awareness of pesticide is not properly in farmer or other utilizers. So very, very important to understand what type of pesticide is there and how to utilize that quantum, how much quantum you should utilize. So herbicide is a one type of the pesticide. So whenever you are herbicide, there is a chemical that kills the plants either to prevent or control them. So modern synthetic herbicides are often used to control invasive plants. So whenever you are utilizing herbicide, so don't keep along with the fungicide and other because this is a for burning of the kills the plant and other is a growing of the plant. So you have to distinguish herbicide and other insecticide, pesticide. So fungicide is a second type of the pesticide is also one chemical compound that prevent or control the plant disease contact fungicide from protective barriers on the outside of the plant to prevent diseases from the preventing the tissues. Third is a rodent insecticide used to kill the rodents such as rat and we are utilizing in many times in our house also in storage areas also is particularly rodenticide. Then insecticides used to control the kill insects. So this is a different utilization than the herbicide and all this. Carbamate, a group of the insecticide that work by the inhibiting enzymes that important for the nervous system function of the insects. This lead to the paralysis and death. Then organochlorine insecticide. Organic compounds that are the attached to high or more chlorine atoms. They were on the first category of the pesticide very synthesized. One more insecticide is the organophosphorus insecticide. Instead of the phosphoric acid that are the commonly used as an insecticide to control pests in agriculture, buildings, and the homes. One more nowadays biopesticide also one of the you can say organic pesticides. Pesticide based on the natural products or microorganism that control pest using non-toxic mechanism. Biopesticides are used to protect crop for the pests, insect, fungal, bacterial, and viral. So that's why type of pesticide and their uses are very, very important before starting utilization of these pesticides. So we will see the wastewater, water management in pesticide sector, same like this chemical sector. Only some parameters are slightly different. Means discharge parameter. Otherwise, this is a common for all chemical sectors also. So water consumption in pesticide processes mostly happen in the processes because lot of cooling, heating is required in the processes. That time process utilization is there. Cooling towers, boiler, and domestic purpose. Water source in Gujarat, if you see this GIDC, if you are from the Maharashtra, so MIDC, like this, there is a corporation many times. If you have bore well, then you have to take permission from CGWA permission required. But major part of chemical industries in GIDC, MIDC, and depend on the corporate, depend on the your state, that corporation and industrial estate there. They are providing water source also. But if you are utilizing bore well water, if you are not supplied by your corporation, then bore if you are wants to bore well, then you need CGWA permission. Central Groundwater Authority, CGW. Wastewater generated from process, industrial cooling, and generated wastewater which is cannot be used back into the processes without treatment. So this is a slightly definition of the wastewater. Without treatment, you cannot utilize recycling again or discharge. That's called wastewater. This wastewater gets treated in dedicated wastewater treatment plants. We'll see the what type of treatment plants are required in chemical industry, particularly pesticide sector. Almost all facilities in pesticide is required in other chemical sector also. With only slightly there is a destruction of the toxicity required in pesticide sector. Is a difference from other sector. So approach towards treatment and disposal of wastewater. One is a non-ZLE system. This is the first approach. So for that industry required ETB plant containing primary, secondary, and tertiary. Disposal may be the common effluent treatment plant again for further treatment and disposal to sometimes river, sea, and land, depend on the situation of that industrial estate. Second approach will be the ZLD system. ZLD system required primary, secondary, and tertiary effluent treatment plant, followed by RO, ME, and ATFD. And generated salt we are sent, so you should send to the TSDF factory, common TSDF facility, land filling site. And generated ME condensate and RO permit should recycle into the processes, cooling tower, and other utilization in the process. So that is called zero liquid discharge unit. Third approach is that you partially ZLD system. So partially means you have some discharge norms like 100 kL. If you are generating more than 100 kL, then additional water you should recycle back into the process like ZLD, above ZLD at 100 kL should be discharged after primary, secondary, and tertiary treatment. Another effluent you should recycle through RO, ME, and ATFD. Why wastewater treatment is important in the pesticide as well as chemical industry? To avoid environmental pollution and health impact, to meet CETP discharge norms, then deep sea discharge norm, water quality for the recycling and utility. Whenever you want to utilize the water, treated water, so treatment is a very important to recycle. Otherwise, your engineering atoms, yeah, your reactors or your cooling towers will be damaged if you are taken this without treatment water. So this is a very important. But whenever you want to ZLD implementation, yeah, discharge to deep sea, yeah, discharge to river, discharge to surface. Very important in chemical industry as well as in pesticide industry. That is a segregation part. Then only you can achieve the desired norms. Otherwise, very difficult area to treat chemical industry, yeah, pesticide industries effluent. So we'll see how to segregate this generated effluent in pesticide sector as well as chemical industry. So majorly, there is a four type of wastewater. One is the from processes, chemical processes required some washing, uh, generation water in reaction, distillation, and all these things. So remove the water from that particular final product. So there is a lot of generation of process effluent. Then utilities like cooling tower, boiler blowdowns, like this, there is a generation of utilities. Third is the washing and cleaning activity of equipment. Then fourth is the sewage water. So like this, we are segregating major part in industry. And on micro level, again, we'll see how to uh, segregate the effluent in chemical industry. So this is by experience. I have divided into some segregation part. This may not be written in your book or syllabus also anywhere, but this is a by experience. We have decided this, and we got result on that. Is if you segregate like this, then we are getting the results for pesticide sector as well as chemical industries. So if you are low COD and low TDS effluent, if COD is a 5,000 and TDS is a 10,000, criteria is like this. If BOD is a more than 30% of COD, then you can take into biological treatments. Biological treatment can be the activated sludge process, MVR, MBBR, depend on the your technology accepted. So this is a primary, secondary, and tertiary treatment. Secondary treatment can be the activated sludge process, MBR, MBBR, like this. If BOD is less than 30% of COD, because in biological treatment, COD BOD ratio is a very, very important. Generally, in chemical industry, 30% BOD is there. But if you have gone to the food industry, yeah, alcohol manufacturing industries, then you'll get about 50% BOD ratio, BOD COD ratio. But generally, in thumb rule, in chemical industry and pesticide industry, you get about 30% only. If less than, then need pre-treatment like oxidation system and followed by ETP. If total nitrogen is more than 10% of BOD in Arabic system, then also pre-treatment is a very, very important, like stripping or penton and all this thing, and followed by biological treatment. Because ammonical nitrogen is impact to the biological treatment because it's a toxic compound. So you have to destruct the ammonical nitrogen first. Yeah, recover that ammonical nitrogen and then followed by biological treatment. So this is the first type of the segregation in chemical industry and pesticide. Second is the high COD and low TDS. If COD is due to the volatile organic compounds, if your chemical is a volatile organic compound, low boiler compounds, then need stripper and followed by biological so that your high COD will be removed. That may be your product, that may be your solvents, that may be your raw material. You can reutilize in your process or you can destruct by other methodology that volatile organic compound and dissolve CODs you can take into the biological treatment. If BOD is a low, having toxicity, so need a again oxidation system, increase BOD COD ratio, and followed by biological like penton, chlorination, ozonation. This is advanced electrocoagulation like this. Third type is a low COD, high TDS. TDS up to 4% means 40,000 milligram per liter. If COD is not due to the solvent, you can do membrane separations, multiple effective operator followed by biological treatment for condensate treatment because COD is also there in condensate, so need treatment again. Fourth is a low COD, high TDS. If COD is due to the compound having the high boiling point, you can go directly to multiple effective operator and condensate can be recycled back into the cooling towers because this is a COD having high boiling point. So your organic content will be then the particular in salts and not in condensate. So condensate water can be utilized into the processes or cooling towers. If COD is due to the compound having low boiling point, then ME followed by biological treatment because biological treatment required due to the condensate having some COD level. Fifth category, high COD, high TDS. So if COD is due to the compound having low boiling point, then steeper required and you can take ME or incineration, depend on your COD. High COD, low TDS with high CV value. If very, very high COD, 1 lakh, 2 lakh COD, and TDS is a low, chloride percentage is below 4% due to this TDS, maybe due to the calcium sulfate or something other compound than NaCl. Maybe chloride is below 3%. Then here you have to send to the co-processing. Co-processing means you have to send to the cement industry because your effluent having some calorific value, organic effluent may be there. That CV value is about 2500 kilocalorie and chloride is less than below 4. Then cement industry utilize as a fuel. As of today, they are utilizing coal as a major fuel. That can be replaced by this your residues and effluent having the CV value is above 2500 kilocalorie per kg. So this is a very good motivated by government of India and state pollution control board also. And they are enforcing to the industries also key send your effluent to the co-processing at cement industries because there is a lot of carbon footprint reduction as well as utilization as a fuel. High COD, high chloride, very high S content, uh, toxicity, and then required only incineration. Nothing else. Incineration is a slightly fuel consumption, equipment, and cost also required very high. Then utility effluent like boiler blowdown, cooling tower blowdowns, you can take into the ROME, ATFD. If you are ZLD, if not ZLD, after primary treatment, you can discharge to depend on your location to CETP or river or sea. Sewage effluent, uh, you should treat internally through STP and treated water you can utilize into the cooling tower or gardening, green belt development. So this is a segregation part. This is a very, very important for chemical industry or pesticide industry, this segregation. Then only we'll achieve a desired result in your industry. So we'll see the effluent treatment plan in the pesticide sector as well as other chemical sector is the same, not much more different. Only in pesticide sector, in primary, you can put pH up to 10.5 so that any pesticide compound comes from your plant processes that will be disturbed through lime. So you should need pH at primary level 10.5 in pH. In other chemical industry, only pH can be 8.5 to 9. So here also treatment mechanism like physical, chemical, and biological treatment required. Primary, secondary, and tertiary you can say. Preliminary treatment, both physical unit operation and chemical unit operations required. Sometimes advanced oxidation systems required before before PTB. Primary, both physical for SS removal, chemical coagulation and flocculations methods are used for treatment. Biological treatment, activated sludge processes like aerobic processes, MBR, MBBR, and SBR, sequential bioreactor. And if your COD BOD ratio is a very high, anaerobic processes like food industry and alcohol industry utilize anaerobic processes, but chemical industry and pesticide industries mostly utilize aerobic processes because there is a COD BOD ratio is below 30%. That's why. Tertiary treatment, both physical and unit operation there. But whenever you are going for design, yeah, commercialize your effluent treatment plant for greenfield project, yeah, new plants. So treatability study at lab level, pilot level is a very important for aerobic system like ASP, MBR, ABBR, and NACR. So anaerobic also you have to check. Resident time also very important for design the any equipment of the ETP. pH, initial raw effluent pH, TDS, ammonical nitrogen, SS metal, and what type of result required. On that basis your aeration tank design also MLSS, MLSS, DO. These are very important before you are designing this. Performance monitoring, quantity and qualitative analysis is a very important for stage wise. Uh, Stage wise sampling also very important to analyze your performance on daily basis to ETB plan. So this type of effluent treatment plant you have already seen me. This is a biological treatment plant. RO is there, STP plant is there. So like this sewage treatment plant here, sewage plant is nothing else. Means this is also like activated sludge process, MBBR, MBR type, activated compact type sewage treatment plants now available in market. So generated treated water should be utilized in gardening, green belt development, or cooling towers. So this is a very important. Don't without operating STP. This is a very good recycling system right now, and we are getting result like the 10 ppm BOD in outlet, COD maybe 30, or SS maybe 10 in that particularly STP plant. So this is a easily recyclable water, available water to you in chemical industry as well as pesticide industry. This is a flow diagram, particularly activated sludge process. If you see this primary treatments, then oil separation, clarification, equalization, neutralization. Then anoxic tank, if you are nitrate compound there. So anoxic is a very important to reduce ammonical nitrogen, and then aeration, because this ammonical nitrogen is a toxic to the biological treatment. So anoxic tank is reduce the ammonical nitrogen. Then clarifier, post treatment means tertiary treatment, maybe activated sludge process having the sand belt filter and carbons sometimes chlorination and all these depend on your effluent characteristic. Second is a MBBR. This is also almost the same flow diagram, but only aeration tank having a MBBR, so that this is a compact type aeration tank. You need a small size compared to activated sludge process, because you are utilizing media here. Not only diffuser system is there, but media is there only. So due to that media, you'll get area is a more for particularly biomass development. That's why required aeration tank slightly less. Otherwise, same process there. Sludge generation also less compared to the activated sludge process here. One more MBR, membrane bioreactor. This is also same. Only you are not required clarifier here. So MBR is working as a clarifier work, and you get to very clear water like suspended solid maybe 10 to 20. Other two activated sludge process SS value maybe 80 to 100. Here 10 to 20 only, and you can increase your biomass from 3000 milligram to 10,000. So you can. This is also one compact uh, activated sludge process. What is a ZLD? ZLD nothing else means you are generated effluent, you are recycling back into the process, and particularly cycle there is a generation of solid waste like salts. The salt should be the same to the landfilling. So need effluent treatment plant as well as uh, RO system and multiple effective operator for to maintain ZAD. Or your sewage water also required to treat and recycle back into the process. So nothing gets zero record discharge. We already seen it now. Pre-treatment is a important part we have seen in segregation. Whenever there is a high COD and you need to treat into the ETB plant, then required advanced oxidation processes. So advanced oxidation processes like photochemical oxidation, catalytic weighted oxidations, ozonation O3, electrochemical oxidation, and penton oxidation. And penton is a one scientist. He has oxidized the highest chemical effluent with S2O2 and ferrous sulfate on pH is about 3.5 and generate OH radical. OH radical again the oxidation and reduction in your chemical. If you see this, how the generate OH radicals, this is also shown here. But this is a costly chemical methodology, chemical treatment methodology. So that right now there is a lot of oxidation, other oxidation methodologies are in market like chlorination, ozonation. So here also whenever you want to the pre-treatment, preliminary treatment by penton, you first take lab trials, pilot trials, and then only go for chemical commercialization. Parameters need at inlet and outlet. You have to see PS, COD, BOD, and ammonical nitrogen. But you have to see the performance on both sides, quality as well as quantity. Because quality required because we are followed by the effluent treatment plant. So again, your penton treatment is a very important to run actuator stress process or ETB plant. So that is a qualitative and quantity because you have to see the batch. This is mostly a batch process penton treatment. So batch time, batch resident time, and result are very very important. So reverse osmosis, it is a process where membrane used and membrane remove the impurities like suspended solid, TDS, other impurities from that particular water and pure water, almost pure water we are getting in the permeate and generated reject. Sometimes again you have to concentrate it by HPRO or directly taken into the multiple effective operator or evaporation system. Whenever you want to install RO, here also right now the in market lot of pilot plants available. You give a refund and take trials at that place because very very sensitive membrane equipment. Many times that will be the damage by some solvents as well as pre-chlorine. So need to check your effluent in that membrane. Many times you have to take deep test also for your effluent so that membrane life will be increased. Here also parameters are very very important to perform like silica, hardness, turbidity, pre-chlorine, ammonical nitrogen, solvents, organics, TSS, TDS to daily basis you have to monitor at inlet and outlet so that you will get qualitative and quantitative performance of the particular RO systems. One more equipment, multiple effective operator. Once your generate reject in RO, yeah, directly processes high TDS effluent like 4% to 10%. Then you have to utilize this multiple effective operator to separate out the your salt and generated condensate you can recycle back into the processes, cool it down, or depend on your characteristic, you should utilize again treatment and utilize into the processor or discharge. So here also many consultant outside available to take your front and trials because here also very very important many parameters like silica hardness. If you have not properly pre-treatment here, then your multiple effective operator operation is a very very difficult. uh, almost they are choking, scaling, and all these thing issues will become. So for that, proper parameters monitoring before installation and pre-treatment also very important, like RO as well as multiple effect diaphragm. Then only your equipment life and less maintenance and running hours will be increased if you are properly pre-treated your equipment then only. So IITFD is one more equipment after this concentrate your effluent up to 30%, then your feed will be the ATFD, so that you can again concentrate your salts up to moisture 10, below 10%, 5% like this. So this is nothing else, one of the uh, single stage evaporator. Here steam is required about 1 kg to 1 kg steam required for effluent evaporation. In multiple effect evaporator, required zero point 0.3 to zero point 0.4 kg steam for 1 kg evaporation of effluent. If you see the CPCB effluent standard for pesticide sector, almost all parameters same like other chemical industry, but only if you see this bioasset test and other pesticides required, they have given concentration of pesticides like DDT 0.01 milligram per liter. Bioacetase is 90% survival peace after 96 hours in 100% effluent. One more, there is a requirement in pesticide sector is a toxicity factor 2, toxicity factor 4, that is in 48-hour half dilution required fish survival. So like this, there is a different. Otherwise, all other parameter like metals and all these things is the same like other industry. Only pesticide and bioacetase is slightly different than the other sectors. And depend on the your discharge, where we are discharging. Again, slightly there is a parameter like COD, BOD. There is a difference. If you are discharging to river, then 250 COD, BOD maybe 30. If you are discharging on surface, then 100 COD required, BOD required 30. If you are discharging to marine, maybe 500 and 100 BOD, uh, COD and BOD there. So depend on the where we are discharging, slightly limit will be the change here. So we'll see the air pollution so measure also important to pesticide sector or and other chemical sector also. Almost same pesticide sector, but there is a norms is a different than one example I'll give here. So pesticide sector PM requires a 20 milligram per nm meter cube. Other sector is a 150 milligram because pesticide there is a particulate matter of pesticide is a toxic to atmosphere, environment, and human health. That's why there is a 20 milligram per nm meter cube, and other sector is 150. Like ammonical nitrogen also 175, other sector here maybe about 30 milligram per nm meter. Like there is, we'll see uh, what difference in other industry. So generally in chemical industry as well as pesticide sector, there is a two type of gases emissions. Three type you can say. One is a flue gas emission. Wherever we are utilizing fuel like coal, um, biomass, gas, so diesels and all these things. It's called flue gas emissions, boiler, DG set, and all these things. So there is a generation of the emission like PM, SO2, and NOx. Depend on the fuel, there is a air pollution control measures are provided. Process gas emission, unwanted gas depend on the reaction, the chemical reaction or fugitive emission of particular reactor. The unwanted gases existing into the atmosphere via wind, vessel. So need some air pollution control measures like the weight scrubber, venturi scrubber, carbon scrubber like this. Fugitive emission is one of the source from the equipment operation and activities. Need proper control for fugitive emissions. So we see So if you this see the distinguishing of the three part, fugitive emission, flue gas emission. So process emission are like PM, SCl, NOx, chlorine, SO2, acid mist, SBR, ammonia, HF. Depend on that process and chemical reaction. But particular flue gas emission only three parameter PM, SO2, NOx. For PM control, generally utilize ESP, cyclone, and back filters. SOx, FGT, dry scrubbers, injection. Dry scrubber means nothing else. So that is a your lime addition along with coal. NOx low, NOx burner systems available. And scrubber, process scrubber, we'll see one more slide we have provided here. So PM water cyclone separator, back filter, and ESP. SOx wet scrubber. NOx already. VOC carbon and thermal destruction. Thermal destruction means you have to take into the particularly fume incineration about 500 to 800-degree temperature and generated VOC we have to destruct there. Ethyl mercaptan, thermal destruction, and NaOCl solution you can utilize. For ammonia, water, and acidic H2SO4, you can utilize media in this scrubber. If you have chlorine generated, then caustic solution required. This is a media. H2S, then alkali scrubber required. HF, then NaOH, alkali scrubber required. SCN also alkali scrubber required. So like this, there is a pollutant and scrubbing media we have listed here. Phosgene, if you are generating, then caustic and water is important for. So this is a air pollution control equipment for particulate matter like cyclone separator, multi-cyclone back filter, second, and electro precipitator. So available only ESP required a lot of capital investment as well as particularly operation cost. But results are very, very good. You are getting below 10, 20 ppm PM per particulate matter. Cyclone separator also equipment for to control PM, but not efficiency like ESP. But you can multi-cyclone separator and you can achieve below 150 particulate matter here. Back filter, we are getting the 42, 60, 70, 80 uh, PM. So back filter also one of the efficient equipment for ESP. This is a very, very efficient equipment, electrostatic precipitator ESP. Only the capital investment is a high, operation cost is high. So most of the coal-fired boiler utilizing ESPs to achieve the desired norms. Control measures for process emissions. So depend on the dry or wet scrubber. Wet scrubber means pack type column towers, plate tray column, venturi, and all these things. So this is a type of the process emission. Depend on the process emission. We have already seen that media for particularly circulation. So here is a media and the distribution of that media in the particularly packed column tower is a very, very important. So distribution system is a very important. You have to optimize the scrubber media for concentration, normality, pH, gravity. Depend on that, you can select the media as well as optimize that media on daily basis as per your operations. Pack bed scrubbers, yeah, you like look like this. There is a distribution system that many times that distribution system choking, leakages, bypassing, then you will not get the proper result in the particularly packed tower scrubber. So annual maintenance, 6 monthly maintenance, cleaning, and very, very important. Many times that pack type interlock saddles packaging material may be there that will be choking there, so need a proper cleaning on quarterly basis, 6 monthly basis. Then only you will get proper results. And your monitoring part on the monthly basis, sometimes fortnightly basis. So this is a venturi scrubber. This is again one of the efficient equipment in the industry to scrubbing the particularly gases. Because here is here injecting or media in the venturi, and there is a gas also injected in same place. So contact area is a very high. So there is a absorption, yeah, absorption or depend on the reactions, very high contact area here. One more control the technology for air emissions. Yeah, here is a summarized part about nothing else. So recovery technique for VOC and inorganic gases like selective membrane separation, condensation, absorption, wet scrubbing, and steam stripping is required. Then abandonment technique for the VOC and the inorganic gases is biofiltration, bioscrubbers. All these things methodology, clearing methodology is there. Recovery and abandonment technique for the like cyclone separator, ESP, wet dust scrubber, two-stage dust. So you can get recovery of your product also. Dry absorption injections, semi-dry. These are all methodologies to utilize your air emission control techniques. Dry scrubber, lime and alkali scrubber for the SOx reduction. If you see the air pollution from the pesticide industries, mostly like PM, SO2, NOx, SCL, SBR, H2S, SO3, ethyl chloride, ammonia, P2O5. All these are the compounds generated from the processes. But pesticide sector, another sector, if you see the norms, SCL 20, other sector are also 20. But chlorine, if chlorine see the from pesticide sector require 5 milligram, and other sector is a 9. H2S pesticide sector required 5, another sector 45. P2O5 10, other sector may not be have P2O generation or limit. Ammonia pesticide sector required 30, and other chemical sector required 175. PM with pesticide compounds is a 20, and other sector 150 to 800. If you see the other sector means like cement industry, see the 800, there is a PM they are allowed. Methyl chloride is a 20, SBR is a 5. Other sector may not be generating. That's why there is a no limit. Here also performance monitoring depend on the quality and quantitative waste required to you have to see the efficiency of the your scrubbers, added air pollution control measures system like ESP, back filter, scrubber, venturi scrubber, all these things by qualitative and quantitative. So efficiency monitoring is a very, very important on both angle. Otherwise, many times what happen, your production quantity is increasing, but your scrubber is not changed. So quantitative and qualitative analysis is a very, very important. You know. So one more OCMS online continuous emission monitoring systems right now is applicable to all chemical industries as well as pesticide industry. So you have to monitor. Previously, we are monitoring monthly two time only, monthly one time. But right now, your boilers, your process tax is continuously monitoring and connecting to the pollution control board websites like CPCB, SPCB, depend on your state pollution control board where you are located as per industry. So this is also one requirement, and they are monitoring our performance, industry's performance. If any deviation, they are giving alerts and all these things. So corrective action doing immediately basis, and people also alert ki nahi, nahi, mera data is going to the CPCB side, CPCB side. So I have to perform properly, and this is a good initiative done by Indian government like CPCB and SPCB. One more important area for chemical industry is hazardous waste management because any chemical process there is a generation of effluent as well as hazardous waste. Hazardous waste also dangerous potential like harmful to our health and environment. So you have to take care. Hazardous waste can be liquid, solid, gases, or sludges. It may be causes increase in the mortality or severe illness. If you are dumped anywhere without treatment, then you'll get impact on the environment as well as health also. So very, very important to how to you are collecting hazardous waste, how to treatment disposal, where we are disposing, what treatment you are giving to disposal that particular generated hazardous waste. So very, very important. I will see, but waste always there is a cost or carbon footprint. If you are generating waste, if you are not recycling, yeah, you are not converted it into valuable products. That is costly as well as there is a generation of the CO2 during the treatment. So there is a hierarchy. Avoid and reduce the waste. So you may be having R&D people, yeah, process improvement people. So give them job key how to avoid the generation of the waste by improving the existing uh, operation methodology. Yeah, raw material changes. Yeah, distillation column by continuous to batch to continuous, like these changes, and how to avoid at process side. You can see. If I generate how to reuse that waste, how to recycle that waste, how to recovery improvement from that, and if you are generate recovery into the energy means you have to send to the coke processing into the cement industry. And if you not avoid upper part, then treatment is required and disposal also required. Uh, Last treatment. So this is a pyramid for waste management. Here also approach should be there. Environmental management approach for particularly waste and effluent. If you see this contribution to carbon footprint, if your effluent is a incineration side, your effluent going to the incineration, then higher cost and a higher carbon footprint. Then second part is a chemical treatment like Penton, ME, reverse osmosis, and ETP and STP. So if you see the eco-friendly system, so ETP and STP is a good system. This is gifted by God because these microorganisms are working for the reduce our chemical contamination here only. So always see your effluent to treat into the ETP possible. Give some methodology, treatment, pre-treatment, and how your incinerable waste, chemical treatment, and effluent treatment, reverse osmosis, treat into the ETP and recycle. That should be the approach, so that you will reduce your cost as well as carbon footprint. So if cost wise, if you see ETP cost, generally you are getting about 200 to 300 rupees per K. Reverse osmosis cost you are getting 400 to 600 rupees per K. ME cost you will get the 1300 to 1800 rupees per K. Chemical may be required 5000 to 7000 rupees per K, and incineration 40,000 rupees per K, 40,000 to 60,000. So depend on cost and multiplication on carbon footprint also in multiplication factor is there. So your approach should be always to how to my incinerable waste. I will give pre-treatment and convert it into ETP side. So that approach always better. So generally in pesticide sector, this much category you will get into the particularly like ETB plus that is a common category 35.3 as per Rule 2016, Hazardous Waste Management Rule 2016 cases. Discarded container also other chemical industries and pesticide sector also. Only distillation residue there is a 29.1 as per 2016 rule. 29 is a sector for pesticide sector. So process solid waste and all these things generate in category 29. Of specific product 29.3, spent solvent 29.4, spent catalyst 29.5. Other is a general category in chemical industry, same like this hydrochloric acid B15 of the sodium. So this is a generation pesticide and other sector also almost generation is same. Only that 29.1 replaced by depend on the pharma, then 26 point, 28.1. generation is slightly different. And disposal here also, and in other chemical sector also, same. Uh, Only if your ETB sludge and if pesticide available, there is stabilization required before land. So already, if you see this, some stream we have segregation already seen above. So toxic aqueous effluent, then incineration required. High calorific value, low chloride co-processing. Then ETB sludge high chloride, then TSDF required. ETB sludge low chloride, then you can give to cement industries. This is also one good example. If chloride is a below 3% and your ETB sludge is having calcium sulfate, then cement industry utilizing as a filler. After clean, there is a requirement of the filling by other like fly ash, gypsum, and all these things. So ATP sludge can be utilized there. Used oil sold to approved recycle. They have good recycling system recovery, and they are again selling into the market. So generated used oil, spent solvent, lead batteries sold to recycler. Flash you can give to brick manufacture, road preparation, and low line area you can utilize. Mixed waste plastic due to cement industry for co-processing because mixed waste having the some calorific value they can utilize as a fuel. Byproduct HCl, sulfuric acid, ammonia, all these things generating the most of the pesticide as well as chemical and sent to end user. Those utilized as a raw material. So that is also good. Chemical gypsum cell sent to cement industry for pillar. Spent catalyst you can send to recyclers. So this is a chemical industries operation part, pesticide industry operation part. Some common legal requirement also very important into the chemical industries and as well as the pesticide industry because there is a lot of global issues to environmental global issues. So there is a international agreements there because someone doing something and someone affecting is happening in environmental area. If America is utilizing more consuming the pesticide, more consuming the fuel, then that not only affect to America, but that affect can be India as well as all countries, other countries also. So international agreements are very important, and all countries should be work on that. That is also very important area because environment is a common area and need control by everybody. So international agreement is also very important. We see that. So Vienna Convention 1980, there is a ozone layer protection agreement was there because in 1980, 78, we know about the ozone layer depletion in Antarctica. But in 1989, there is a Montreal Protocol. So we research on the what type of the compounds there are six compounds that ODS compound and how to take actions, how to protect, how to ban all these things. Monitor Protocol 1989 we have signed all about 189 countries and action also started. Last date is 2030 or to ban all six ODS compound. Then climate change also one of the issue, and then Kyoto Protocol 2005. There is a lot of discussions on the particularly uh, greenhouse gases like CO2, methane, N2O, GFCs, PFCs, and SF6. So due to that, there is a climate change and global warming was there. So in 2005, there is a lot of discussion on that and corrective actions. And there is a Paris Agreement in 2016. So each country, what action should be required, what objective and goal should be there, and you have to support to below 2 degrees centigrade uh, universal temperature. That was the agreement, and people are taking actions like SBTI, CDP, and all these things, ESG, sustainability signing, reporting, and all these things. And India level also, in country level also, there is a goals and life implementation as that is for India. So like this, all countries are taking the initiative. Then one more. Basel Convention in 1992, because there is a lot of developed country have generation of the hazardous waste and they are dumping to the non-developing countries by giving the negative pricing some money on all. That was the effect on the environment. So there is a Basel Convention, and you have to take both countries proper permission, and then only waste should be the transfer from one place to the other place. Like this, there is a Stockholm Convention in pesticide organic compounds. So there is a 12 compounds, 9 are pesticides, because that persistent organic pollutant have the half life size is a very high, maybe about 100 year, 500 year like this. You may be knowing DDT, maybe 30 year back there is a DDT, Deldrin, and all these things, Eldrin, pesticide. So their half life is about 200, 300 years. So then right now is that banned, that pesticide, because that's circulating from the soil, then plant, crops, and life, human life also. So they have banned pesticide. Like this Minamata Convention 2017 also, because protect human health on the adverse effect on the mercury, because there is a one incident in Japan in fish. There is a mercury generating effluent discharging the effluent in river and sea. Then lot of fish affected and human also affected due to that fish eating. So there is a mercury ban in many manufacturing units, like caustic chlorine plant. Previously, that membrane is mercury membrane, but right now that ban now is a membrane type, other membrane type there. So India level we have organogram like this. Central government, I have cabinet Ministry of Environment and Forest and Convention. Under that Central Pollution Control Board, Ministry of Environment and Forest. Then state level also state government have state and forest ministry, and under that state forest environment department there, state pollution control board and regional officers are there. Central pollution control board also have about a regional officer, different ministry also have regional officer all over India. If you see this environmental acts also after this 1972 attended one US EPM meeting by our Indira Gandhi. And first act is published in the India is a Water Prevention and Control Act 1974. But there is a lot of air pollution issues also found during the operation of the chemical industries, particularly. Then one more act published in 1980 called Air in 1981, the Air Pollution Control and Pollution Act 1981 for checking the pollution or pollution control board. But if you see the there is one incident in Bhopal in 1984. So before 1984, there is only two acts, water acts and air pollution act for sources only. Sources means like your stacks, boiler stack, flue gas stack, and all these things. There was a condition. There was no condition for ambient air and all these things, fugitive emissions and all these things. And this incident happened in the storage tanks. So there was a lot of questions to the authority and government to how to punish that particularly industry, which act which rule is applicable to punish that. But there is a question mark. That's why one more act published after Bhopal incident, that is the Environmental Protection Act 1986. That act called is the Umbrella Act. So under this act, any chemical industry, any pesticide industry, anywhere, any location in their premises, outside premises happen due to their chemicals. Now they can punish by this under this act 1986. That's why this act is called Umbrella Acts. One more question was after that Bhopal incident, whom to pay to the particularly affected person, yeah, damaged property. That was the question with government. So that's why. one more acts published, that is called Public Liability Insurance Act 1991. So under this act, there is a mandatory to chemical industry and other industries to pay their premium and collect revenue. They can collector can utilize their collected fund from chemical industry during the incident as well as after incident also. So that's why all industries are applicable depend on their capital investment, the premium decided, and you have to pay premium. Even though there is a lot of issues due to the chemical industry and lot of complaint, and there is a court matters due to NGO and public given to court, Supreme Court, High Court. But lot of cases in High Court, Supreme Court, there is no real concentration on the environmental cases. So India level there is a decided key one more separate one court is required. So that's why there is a 1 month for publication. There is a National Green Tribunal Act 2010. Under this act, one more court, NGT court, has introduced, and now separate environmental cases handled by the NGT, and now focus on the environmental cases also. One more rule, important rule published, hazardous waste and other waste management transboundary movement rule in 1989. After that, 2003, after amended in 2008, now in 2016, and amended in time to time, maybe yearly two times. This is a very, very important rule 2016 under this EP Act. So, how to generate hazardous waste processes, different category, different types of industries, and how to disposal that methodology in Schedule 1, Schedule 2, Schedule 3, and Schedule 4 given. All these things clarity given by under this rule. Statutory requirement to separate pesticide. Almost all rule I have already told biomedical waste and all this noise is also applicable to the other industries also. Only particular pesticide sector norms are different, and pesticide sector required CRV registration to particularly industries uh, for your pesticide manufacturing. That is only difference. Otherwise, all commons legal requirement, other chemical industries required as well as here also. And you should not manufacture banned pesticide like DDT, LD. That is also one requirement to pesticide sector compared to other sectors. Given here video.
What you choose makes a big difference. the right choice. Let's choose Mother Earth every day.
So thank you so much. Uh, we have only 1 hour, so let us take care of it together. So thank you so much.
Yes. Thank you, sir. Am I audible?
Yes, absolutely.
Yes, yes. Thank you, sir, for sharing your knowledge. Participants, you may raise your hand if you have any queries or if you want to interact with Karhale, sir. Kindly raise your hand so that I can unmute you. Okay, I guess, Karhale, sir, we don't have any questions.
Yeah.
You explained in such a way that each and everything got cleared.
Okay. Thank you.
Okay. Any questions? Yes, there is one. Just a moment. Yes, Mr. Damodar Prajapati, you can unmute yourself.
हाँ सर, मेरा एक क्वेश्चन था।
Yeah. Yeah.
हेलो
Yes. Yes.
सर, अपना जो वेस्ट रहता है उसमें जो ऑर्डर रिमूव करना है तो उसके लिए कौन सा प्रोसेस सही रहेगा?
ऑर्डर है उसमें ज्यादा।
हाँ
ओके। सो ऑर्डर के लिए कौन सा कंपाउंड्स है आपका प्रोसेस से कहाँ से तो आता होगा जो ऑर्डरस कंपाउंड है। जैसे लाइक एक एग्जांपल देता हूँ, इथाइल मर्केप्टाइन इज अ ऑर्डरस कंपाउंड, बराबर। अमोनिया इज ऑर्डरस कंपाउंड। सो आपको फाइंड आउट करना पड़ेगा व्हाट कंपाउंड यू आर कंट्रीब्यूटिंग दैट स्मेल, बराबर।
एक तो
डिपेंड ऑन द
एमोनिया है सर, एक तो एमोनिया है एंड सेकंड वन इज मिथाइल मर्केप्टन।
हाँ। सो अपने एक स्क्रबर मीडिया के लिए इथाइल मर्केप्टन के लिए अल्कली और थर्मल डिस्ट्रक्शन अपने एक मीडिया देखा था अभी स्क्रबिंग के लिए। सो यू नीड सम थर्मल
नहीं सर,
डिस्ट्रक्शन।
in sorry sir, in liquid effluent we have to reduce the order.
हाँ, उसमें भी यू हैव टू अटैक ऑन द योर प्रोसेसेस फर्स्ट। आपका जो प्रोसेस का पार्ट है, R&D का जो पार्ट है, उसमें यू हैव टू अटैक कि मेरा कंपाउंड जो आ रहा है पर्टिकुलरली रेसिड्यू में, उसको मैं सोर्स पे अटैक कैसा करूँ। एंड देन डिस्ट्रक्शन के लिए आपको हो सकता है देयर इज मे नॉट बी रिएक्शन विद योर रेसिड्यू। सो उसको समझो एसिडिक है आपका, जैसा अल्कली बनाएगा तो इथाइल मर्केप्टाइन इज अ डिस्ट्रक्शन। थर्ड इज अ क्लोज हैंडलिंग सिस्टम। इथाइल मर्केप्टन क्या है, वेरी वेरी ट्रेसेस फॉर्म में भी आपको ऑर्डर नहीं देता, तो क्लोज हैंडलिंग सिस्टम उसको यूज करके प्रॉपरली ये ढक्कन वगैरह जो भी आपका रेसिड्यू ड्रम में भरता होगा तो उसको क्लोज ड्रम के लिए भी एक आता है सिस्टम, जिसमें आदमी को भी जाने का जरूरत नहीं, ओनली हैंड अंदर डाल के आपको वो ढक्कन लगा के यू हैव टू गिव टू द कॉमन इंसिनरेशन। कॉमन इंसिनरेशन हैव डिफरेंट फैसिलिटी फॉर द ऑर्डरस कंपाउंड के लिए, जो ड्रम जलाने के लिए पैरालिसिस है या उनके पास सक करने का सिस्टम है, स्क्रबर करने का। सो ओनली जनरेट होता है तो अवॉइड कर सकते हैं, बट जनरेशन के पहले आपका प्रोसेस टीम शुड बी द वर्क करना चाहिए कि मेरा इथाइल मर्केप्टाइन कैरी ओवर नहीं होना चाहिए रेसिड्यू में। अभी वो कंस्टेंट है, तो प्रॉपरली क्लोज हैंडलिंग सिस्टम्स एंड गिवन टू द कॉमन फैसिलिटीज, और उसको अल्कली डिस्ट्रक्शन पॉसिबल है तो रिएक्शन नहीं है आपका इसमें, तो यू कैन ये कर सकता है, बराबर। सो डिपेंड ऑन द आपका कॉन्सेंट्रेशन कितना है अल्कली का, इसमें कोई हजार्ड नहीं ना अल्कली करेगा तो उसको या क्लोज हैंडलिंग सिस्टम या सोर्स पे अटैक करना पड़ेगा, या थर्मल डिस्ट्रक्शन आपको खुद को एक इंसिनेटर सक करके, क्योंकि इथाइल मर्केप्टाइन डाइल्यूटेड फॉर्म में वेरी वेरी लेस, तो आपका जो सकिंग जहाँ पे फील करता है ड्रम्स, बराबर, वहाँ पे एक सक्शन देके थर्मल डिस्ट्रक्शन 400 500 का एक फ्यूम इंसिनेटर भी लगा सकते हैं आप इथाइल मर्केप्टाइन और अमोनिया के लिए भी। और अमोनिया है तो अगेन सकिंग और थोड़ा हीट देके यू कैन वाटर स्क्रबर भी प्रोवाइड कर सकता है। यू विल गेट 20% ammonia solution, you can utilize it into the processes or sell to the outside also. वो भी एक देख सकते हैं, very high concentration. Damodar?
I hope your doubt is clear. Damodar, I guess there is a network congestion at his side. We can move on to the next question from Ravi Tank. Ravi Tank, sir. Please
Yeah, Ravi.
unmute yourself.
Yeah, thank you very much, Dr. Hiral. Am I audible
Yes.
properly?
Yes,
Yes, yes.
yes, yes. You are audible, sir.
Thank you very much for unmuting me. And sir, first of all, let me give you congratulations for making this environmental audit FDP a very good interactive one and giving us so many such stalwarts of the environmental section. And today's
Thank you.
session also was very much informative and contentful. So I'm very much pleased with all the contents have been delivered. Thank you very much for that. And with this, I want to have propose one question which I'm having that right now the technology is being implemented in our sector, environmental sector, pollution control and mitigation, like anything, just like data analytics, remote sensing, and all. Now, here, this again, they are very much efficient and effective in measuring the parameters, but they have certain limitations too, in which the kind of we can say manipulation, if you want to do now, that can be done very easily. So this technology has pros and cons associated with it. So my question is, if this remote sensing and data analytics are going to come for auditing and all, so are they such effective and seen as certain yardstick for assessing this parameter in the pollution and control sector environmental audit case studies, please?
Yes, yes. Any instrumentation, any automation, definitely there is a improvements we are getting. Miss, if I see this in process part also, previously only dial type thermometer, dial type pressure gauge was there. So people are manually checking, going with the reactor and seeing that all these things. So in between there is a gap because there may be 100 reactor seen by one operator or one supervisor, and maybe there is a gap per dial thermometer. Once that is gone into the PLC, DCS, and all these things, now that time is reduced, miss, because there is if you are improve DCS, if continuous processes and all these things, there is a yield improvement, recovery improvement, waste reduction, all these things happen. Same thing, pollution that is applicable to pollution control, major equipment, and all these things. Now, that's why I have told okay, there is a OCMS already established by a pollution control board for discharge the effluent as well as emission of the particularly flue gas emission as well as process gas. That is done lot of improvement. This is happening many times. There is a some instrumental issues or something maybe done by some industry, some factor, and all these things happening in the sometimes depend on the, but there is a lot of improvements after this automation and OCMS and data evolution parts, and industries are doing also. So there may be slightly gap or there may be slightly deviation, but definitely due to the automation, DCS, OCMS, data evolution, there is a improvement seen in chemical industries.
Many times, sir, it is found in the OCMS that the sensors which are installed now, they have got certain layers of certain particles on it. Okay, because of that, it gives many false alarm, and this false alarm again, the readings also they vary like anything. And once it is being taken care properly, means it is AMC or the maintenance is done. Now then again we restart the thing and we got certain readings in some rangeable order.
You are right, Raviji. You are right. You should give industry should give the AMC to particular experts that is there. But right now, many industries having good experience in they have own department like instrumentation, IT and all these things. They are taking care of many times. But there is an annual maintenance,
Maintenance.
periodical maintenance.
Yes,
They
sir.
have systems. There is alarm systems. All these things they have, miss industry have. So they are
Yes,
taking care. And if you are not department, they are giving AMC to the experts, outer experts also.
yes, sir.
But right now, due to the OCMS, lot of improvements happen. Okay, there may
But
be one or two industry may be doing here and there. That is different part.
yes,
Because before OCMS, we are only monitoring on monthly basis one sample for half hour.
yes,
Right
sir.
now, continuously monitoring there. If
Yes,
factor also there, we have to maintain that under limit. Previously, that is no measurement, only half hour measurement in 1 month. Right now, even though one or two industry, there may be some factor, but there is a limit of that factor also. You cannot
yes, sir.
go beyond that.
Mhm.
So there is a lot of improvements due to the OCMS and all this.
Because being an academic institute, Dr. Hiral also might be agreeing, and Rotliwala ji also may be agreeing that if we procure any instrument now, then it's easy to procure, but to maintain, we do not have any grants available. Grant is only coming for procuring them. To maintain them is again a headache. So for industry, it won't be any problem as such. They will be having certain recurring funds which they can utilize in AMC. But again, this sensor technology has its own limitations on which we also have to go hand in hand.
Correct, correct.
Agreed.
But okay,
Yes, yes.
again, there may be research and some maybe introduction part for OCMS again. There may be like PLC upgrade in DCS, like there is OCMS maybe upgrade somewhere in the future. But industries are accepting that part. That is also one good thing. Correct. So not only chemical industries are culprit. Many area today we have in your residential in your home also you see how much chemical we are utilizing is
Yeah.
maybe 20 year back maybe we are utilizing only 5% chemicals in our house. Right now if you see from bathroom to your house cooking area almost all up on 80% we are utilizing chemicals. So there is a definitely there is a some requirement individual requirements also there, so protect them. So many times chemical manufacturing industrial estate ambient air and compare with Delhi. So there is a sometimes better than Delhi. Like this be happening is. So not only chemical industries area to protect environment. Right now is each individual requirement is there.
Thank you very much.
Uh, Next question, Mr. Abhay Nagle, sir.
Sir, pleasure to have heard your presentation and nicely given all the details. Really very happy.
Thank
My question is regarding the refrigerants, sir. I mean, because there are certain notorious refrigerants called R22 and all.
you.
They have a very high ozone depletion potential.
Correct.
As an auditor, how am I justified in telling the industry to really replace it? And if I have to tell them to replace it, what should I really recommend? Something like R134A or R32 or R410A or I mean, because in the government of India has not totally banned it. But
Ah,
if the R22 fellow leaks, it's really going to puncture a hole in the ozone layer.
correct, sir. You're
So,
right.
am I justified in recommending that please change it,
Correct. There
or
is
I
a
should
phase.
tolerate it?
No, 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 not tolerate. There is a phase out direction notification there up to
True, true,
2030. There is no
true.
alternate. There is a manufacturing stop by importing as well as manufacturing. They're like Navin Fluorine, GFL. They are phase out the already phase out many things.
Yes, yes.
2030. We will not get any CFCs after 2030. So there is no question to utilization. Right now, they will utilize up to 2030. There is a lot of improvements also happen worldwide. If you see the particularly ozone depleting substance reduction drastically in worldwide. They can happen. But there is a phase out date is there. That's why we cannot enforce to them to before that. So that's why there may be right now also 80% CFC utilization is reduced. Industry are already changed. Miss. Maybe there is a 10 to 20% is remaining. They will phase out before 2030 definitely. And requirement also there.
Before it is phased out, it may not be a good idea to really tell the industry to replace it. We can only tell them that please
Okay.
beware of it. You will have to replace it at least by 2030. Am I
Correct, sir.
correct?
Sir, already almost phase out that, and alternate also started manufacturing in
Right.
GFL as Navin fluorine. That.
Yeah.
And people
No,
are,
but unfortunately, in India, whatever are the replacements, they have a lot of greenhouse gas potential, though they don't have any ozone depletion potential. But in Europe and all, they have already started using LPG, either propane, butane, or a mixture of that, R370 or R600. And that really, they are not greenhouse gases. Whereas R134A or R32, they have high greenhouse gas potential.
correct, sir. If you
So
see
that's
Aarti, I will give my company, past company as well as here in Aarti Industries also. We are 100% phase out the means ozone depleting substance.
okay. Okay.
Even though
Only
office ACs also we are replaced all these things.
right. Office ACs, refrigerators, everything.
So
True.
almost we are phase outing means chemical.
Yeah.
Maximum 2030 will be there. And there is a good news. Further, there is no depletion of the ozone. That is also one initiative taken at universe level, and really some result we are getting from that.
Yes.
So,
Actually, and during lockdown, it really patched up a little bit.
yeah. But
I have
environment is
one
a
more
common.
question.
Yeah,
Okay.
yeah, sir.
Sorry.
Please. Yeah, please.
Sorry.
So environment is a common area. Need means each person attendance. So that's why I have given consumption of US and our also. We are using 600 milligram per hectare, and America is utilizing pesticide
3,000.
3,000. So that is also affecting. So America should be think about how to reduce that up to India level. Means our power consumption per capita is a very less, and there may be in multiplication about 10 times multiplication power consumption, energy consumption by US, UK. So they should take some stringent target so that there will be good impact on the environment. Yes, sir.
Right.
Yeah, please.
Yeah. I have one more question regarding the burning of plastic waste. I mean,
Mhm.
plastic waste has some calorific value, so it is allowed to be put in the boiler or given to the cement industry. But if it is PVC, particularly the chlorinated or halogenated hydrocarbons or this thing, then there is a danger of dioxin formation.
You are right, sir. You are
And
right.
dioxin, the concentration in atmosphere has to be a few picograms. I mean, so 10 raised to minus 12. I mean, maybe 10 picograms or 50 picograms like that. So how far as a nation we are justified in directing the plastic waste towards the burning kind of this thing without really segregating it into PVC, and I mean there's no problem in HDPE or LDPE or so, but burning PVC, it really pinches me.
Correct, sir. You are very, very right. Because segregation is a very, very important. And then destruction. Destruction also you have to take care of dioxin and furan. Because if I see this burning into the boiler, burning into the incineration, and burning into the particularly co-processing with cement, that is all different. If you are burning into the incineration, required dioxin and furan generation control measures. Was if incineration see the 1150 degree temperature in secondary chamber, so there is a generation of dioxin already there. If you are not quench up to 250 degrees centigrade immediately, there is a generation of dioxin and furan. So
Exactly.
that methodology is required in incineration plant. Correct, sir.
Yeah.
So that can taken care by, but that should be the authority should be the monitor that system is running or not properly. In boiler also, in general boiler, there is no really benching systems. So in boiler, if you utilize that particularly generating substance like furan, so there is really dangerous. Correct. So avoid the boiler, or you can add the air pollution control measure like benching system from 1200 degrees centigrade to 250 degree centigrade quenching system. Then there is a avoid the generation of dioxin and furan. But favorable condition in the cement industry. Any combustion required three T's like time, temperature, and turbulence. So in if you have seen in cement industry, the resident time in common incinerator maybe 3 seconds, 4 seconds. In rotary cleaning cement industry is about 20 seconds, 20 to 30 seconds. Temperature in incineration plant, yeah, boiler about 1150 degrees centigrade. And cement industry have temperature 1800 to 2000 degrees centigrade. Turbulence, most of the maybe incinerator plant stationary chamber may be there. Yeah, sometimes rotary, but cement industry there is a rotary clean, always rotary clean. So there is a turbulence always there. So these three
Turbulence is higher. Yeah.
so these three T's are very, very important in the cement industry. That's why we are motivating this our waste sending to the cement industry, not incineration. So that is a one good thing. And if you see this long rotary kiln having alkalinity, because there is a limestone utilization, lot of limestone required for manufacturing cement. So there is a alkalinity media, total alkalinity. So you are generated dioxin and all these things due to that alkalinity media, long alkalinity media, that is a destruction there. And there is a temperature reduction phenomena there after that. So that's why that is a favorable condition for the all waste as well as chlorinated atom also. But there is also restriction. That's why they are restricting below 3% is chloride. Uh,
Right. Right. Right.
Sir,
otherwise,
in
there is
Vapi region, some of the pulp and paper mill, GPCB has given permission under waste to energy fuel, and they are utilizing waste plastics which generated at their place, uh, uh, and they have a system like dry quenching. That system of dry quenching, they can control dioxin and furan.
then
But of
okay.
course, they have to segregate PVC. That is one of the criteria for the waste to energy projects. And it is given to most of pulp and paper mill industry. And I think two, three projects are already in operation at Vapi.
Yeah,
SOP is also issued in this case. SOP
correct.
by GPCB is also issued.
Yeah, CPCB
They can, if they have a dry quenching unit, they can use waste plastics in their waste to energy boiler.
If you are controlling the dioxin generation, then good, miss. No issue, miss. They
Yes,
are
yes,
recycling,
yes.
yeah. But
Of course, they have also made a criteria that they should first segregate the PVC. The
okay,
least amount of the PVC is permissible.
okay. Then okay, miss. Then good.
I
And
think
one
one more technology, the pyrolysis is also the technology that with that the waste plastic can be utilized. But due to some safety concern, GPCB has, I think, maybe banned this technology, pyrolysis, where there is no issue of the dioxin and furan because it happens, the pyrolysis happens in absence of oxygen. When
correct, correct.
oxygen comes into picture, then dioxin furan will be formed.
But there is a good awareness in industry as well as
Yes, yes, lot many improvements are going
definitely,
on.
definitely we'll achieve something after because if you see this 20-year back, there is no like environmental specialist in industrial. So right now we are gathering maybe itna 150 ऊपर लग रहा है people. So this is a good thing, miss. Again,
And
Yes,
remarkable
sir.
work is going on in the area of the hazardous waste management. Rule
correct, correct,
9, exchange of the hazardous waste, co-processing,
correct, correct.
spray drying.
Lot of improvements there, but parallelly our lifestyle also increasing. That
Yes,
is
yes, yes.
one problem
So,
is if you see this in a house also maybe 20 year back maybe 3 4 days maybe there right now each people maybe about 20 days we have maybe After 1 year, after we are getting that changing that. There is a lot of requirement by for particular lifestyle. That is also one requirement, higher requirement of the chemicals. That is
So
also
thank you
one.
very much, sir.
Yeah, thank you, sir.
Yeah, thank you,
Thank you.
Rotiwala sir, for your nice inputs. And
Thank
I mean, the scaring thing is that only, its concentration cannot be more than a few picograms.
You are
So,
right.
I mean, it's always a matter of worry, but thanks for shedding light on this, that plastic PVC, they need segregation, because other than PVC, they are not going to give dioxin. LDP or HDP is not going to give dioxin.
Yes, yes, polyolefins, that is possible.
Yes, yes. So that is perfectly all right. But I mean, because it's so less a concentration, STEL is so less that
Correct.
it is a little bit scary. Thank you very much again. Thanks a lot, sir. Thank you, sir.
10 year back, there is a monitoring analysis issues also in India. Right now, maybe 2 or 3 laboratory doing that action and
Right,
phenom.
right.
Yeah. So that is
The only
also
agency available, that is Vimta Lab, is available in all over India.
one more
So
area.
also
There
it
is
is
a
a big issue of the so much costly. The monitoring hours is the number of hours is so much high. It's difficult. Actually, one of the participants has asked about this automation. There is a need of development of the low cost methodology for this parameter detection. Like TOC analyzer, I think maybe it costs maybe 15-20 lakhs.
yeah, yeah,
So the innovation is required to develop in this area. Like at a very low cost, the parameters should be measured. Of course, researchers are doing a lot of work. Actually, one of my students doing PhD, and there is an issue of the methane detection, methane and carbon dioxide detection, the mixer, that is biogas mixer. Okay, so for methane detection, GCMS is required. And for that particular one method, it costs about maybe 5,000 for a single sample. And we need to analyze more than 500 samples as it is a part of PhD work. So it becomes so much costly. So we have developed one method like KOH method for CO2 detection, carbon dioxide detection. And like 60% methane, 30% CO2 is there. So we have considered rest of that, like once with using KOH method, we are measuring CO2 and subtracting the concentration of the CO2, we can know the concentration of the methane. Then we validated that method with the GCMS, and the error was around 2 to 5%. And this research published in Elsevier publication. So that kind of the methodology required to research. Like for TOC analyzer, if the equipment cost is 15-20 lakhs, then we must have a method, low cost method.
correct. You are right.
Thank you, sir.
I
Thank
think
you,
that's a
sir.
good idea that, by difference, you get the methane. That's a nice
Yeah.
idea. And if it is validated properly, I think there should not
Yes.
be any problem that it's a 2 to
Yes. Yes.
5% error. That's all. Thank you
And
very much, sir.
nowadays, the number of people are focusing on CBG production, where they will face the issue of the methane detection.
True.
Okay, thank
Okay,
you,
Okay.
sir.
sir. Thank you
Thank
all.
you from my side.
Yeah.
Okay, okay. Thank you, sir. We shall conclude here as our next guest is already waiting in the lobby. So thank you so much, Karhale sir, for giving this knowledge sharing session. Thank you so much.
Thank you so much. Thank you all.
Yes. Ashish sir.